Hello, welcome to another section of Math. Let's look at this question. Solve integral 7 raised to the power 2x plus 10 dx. Solve integral 7 raised to the power 2x plus 10 dx. 7 raised to the power 2x plus 10. What approach do you think can be used to solve this problem? Or what do you think can be done to solve this problem? Substitution, partial fraction, integration apart. Well, in this video I'm going to show you how you can use the substitution approach or the use substitution approach to solve problems of this nature. So without wasting much time, let's get into the video. First, let's write our solution. Let's repeat this. Remember I said we are using substitution approach. Okay, so here we are going to do substitution. We will let u be equal to 2x plus 10. 2x plus 10. Here we are going to differentiate. Now when you differentiate this, you are going to get du, and when you differentiate this, now when you differentiate 10, we are going to get 0 because the constant. Now when you differentiate 2x, we are going to get 2 dx. Now the power of the x is 1, so that 1 will multiply these 2, and that will give us 2. Now when you decrease the power by 1, we are going to get 0. And any variable or number raised to the power 0 is 1. So when you differentiate this, you are going to get 2 dx. Now here we are going to find dx. So we are going to divide both sides by 2. When you divide this side by 2, you are going to get dx. And when you divide this one by 2, you are going to get 1 over 2 du. So dx will be equal to 1 over 2 du. Now let's put this one into the integrals and let's continue from there. One over 2 integral 7u du is supposed to be 7u multiplied by the whole of this, but the 1 over 2 here is constant. So that is why I write the 1 over 2 at the back of this integral. Okay, so let's focus on this one. 7 raised to the power u. Will the substitution approach work here? It may, but it won't be all that easy. There might be some complex calculation that will what we are going to do here is that, because I want everything to be clear and very simple to understand, I'm not going to make the substitution directly from here, but I'm going to rewrite this one so that the substitution will easily work out for us. So I'm going to rewrite this one using natural log. So rewrite 7 raised to the power u using natural log. rewrite 7 raised to the power u using natural log. Now, when you use natural log to rewrite this one, we are going to get ln 7 raised to the power u. ln 7 raised to the power u. Now, mind you, when you rewrite this, whatever you get, make sure when you compute it at the end of the day, you are going to get this same 7 raised to the power u. Okay, so let's rewrite. Here, the substitution approach will easily work out for us. So we are going to do another substitution. We will let m be equal to, because we have already used u, we are not going to use u again. Okay, so we are going to use another variable. So we will let m be equal to ln 7 raised to the power u. ln 7 raised to the power u. Here, from one of the laws of logarithm, which says that log a raised to the power b can be written as b log a. So applying that law here, ln 7 u can be written as u ln 7, u ln 7. So this one is going to give us m is equal to u ln 7. Now let's differentiate. Now when you differentiate this, you are going to get dm. When you differentiate this, we are going to get ln 7 du, ln 7 du. So dm is equal to ln 7 du. Now we want du, so we just divide this one by ln 7 and also divide this one by ln 7. When you divide this one by ln 7, we are going to get du. So du will be equal to 1 over ln 7 dm. Now let's put this one into the integrals and let's continue from there. E raised to the power m multiplied by 1 over ln 7 dm. Though the other part I didn't show something like this, so I didn't bring the constant inside the integral, but here I chose to bring it because someone may think because this one is ln 7, it's because this one is ln 7, that one too is going to be integrated. No, 1 over ln 7 or ln 7 is just a number, so it's treated as what? Constant. It's treated as what? Constant. Don't think because this one is letters or maybe variables, which is ln, you are going to integrate it. No, just treat it as constant. So I just brought it here to I just brought it here to do some small explanation or to say one or two things about it. That is, some people may think because this one is ln, it will be or is going to be integrated. No, 1 over ln 7 or ln 7 is what? A number, and therefore should be treated as what? Constant. So this one we are not going to integrate it. We will just bring it outside this integral sign, or we'll just bring it at the back here, and when we do that it will multiply this 1 over 2. Okay, so here we are going to bring this 1 over ln 7 at the back here. Now when we bring it at the back of this integral symbol, that one is going to give us 1 over 2 times 1 over ln 7, and that one is going to give us 1 over 2 ln 7, 1 over 2 ln 7. Okay, so now here what is inside is e raised to the power m. Now we all know the answer to integral e raised to the power m or e raised to the power p or e raised to the power u. we all know the answer to something of this nature. So integrating e raised to the power m will give us what? The same thing as e raised to the power what? M. Now, if you are wondering why is it that when we integrate e raised to the power m, you worry no more, because I've already done a video to show why is it that when you integrate e raised to the power m, you get what? The same answer as e raised to the power m. So I will leave a link to that video in the description section below at the end of this video. So if you want to find out why, you just go and click on that link and then enjoy yourself with it. Okay, so now let's continue. So what is the answer to this one? E raised to the power m dm. That is going to give us the same thing as e raised to the power m dm. But mind you, the answer will be multiplied by this. So we are going to get 1 over 2 ln 7 multiplied by e raised to the power m. Now that we are done with the integration, we have to go back to the x world. We have to go back to the x world, okay? Because this substitution was just to help us solve the problem at hand. So if you are done with the problem, what do you have to do? We have to go back to the original world, which is what? The x, okay? So e raised to the power m, we know that m is equal to, ln 7 raised to the power u. We know that m is equal to ln 7 raised to the power u. So what we are going to do is that wherever we see this m, please mind you, not because I said wherever you see this m, we are going to put this one there. Means you just come here and put this ln 7u here. No. After you are done with the integration and you are going back to the else world, wherever you see m, just replace that m with what? This one. Okay, so when you replace m with this, we are going to get 1 over 2 ln 7 bracket open e raised to the power ln 7u. Okay, now you remember the other part, it was 7u and we rewrite it to get something like this. Okay, so here remember I said when you rewrite it using natural log, remember when you compute it, it should give you the same answer as what? That 7 raised to the power u. So here this is going to confirm what I said earlier, that when you rewrite and you compute at the end of the day, you should get the same thing at the end of the day. So let's find out if you are going to get the same thing at the end of the day. That is, okay, so here e raised to the power ln 7 raised to the power u. Now let's see what we are going to get. The base of the natural log is e, and already we are having another e here. So because the base of the natural log and this e are the same, is going to cancel out. The natural log and this e is going to what? Cancel out, and it will be left with what? This 7u. Okay, so when the base and the natural log cancel out, you are going to get 7u. Then we multiply it by 1 over 2 ln 7. Now when we multiply this, we are going to get 7u over 2 ln 7. 7u over 2 ln 7. Remember I said we are going back to the x world. Though we started from the x world and we reached m world, and m world was able to help us solve our integration question, and because we are done, we have to go back to where we came from, which is what? The x world. Now we have moved from the M word to what? U word. Still we haven't reached what? The X word. Here also we know that U is equal to 2x plus 10. 2x plus 10, but U is equal to 2x plus 10. So 7u divided by 2 ln 7. Now, wherever we see this u, we are going to replace it with what? 2x plus 10. 2x plus 10. Okay, so let's replace it and see what we are going to get at the end of the day. Now, when we replace it, we are going to get 7 raised to the power 2x plus 10 divided by 2 ln 7 divided by 2 ln 7. Okay, now what does this one tells us? What do you think? Any idea? Now, this one means that problems of this nature, when you integrate them at the end of the day, you should get the same question which was given as part of the solution. If you don't get that, it means you are wrong. Provided this side could have been maybe something like 2x, or maybe something like 5x, something like 10, something like 8x, our answer could have been wrong. But because we are able to get this same thing which was given in the question, it makes our answer correct. Okay, so anytime you integrate problems of this nature, like integral 7 raised to the power 2x plus 10, make sure at the end of the day you get that question, not the integral. I mean, what you are integrating, make sure you get that one as part of the answers at the end of the day, or as part of the answer at the end of the day. Okay, so the answer to the integral question is 7 raised to the power 2x plus 10 divided by 2 ln 7. 2 ln 7. So let's conclude it. Therefore, integral 7 raised to the power 2x plus 10 is equal to this one plus c, is equal to this one plus c, or is equal to this one plus c. Now, remember what I was saying, or what I was telling you. The question is 7 raised to the power 2x plus 10, and the answer that we had is 7 raised to the power 2x plus 10 divided by 2 ln x, divided by 2 ln x, which means that at the end of the day, problems of this nature, when you integrate them, you should get the question, the same question, which was given as part of the answers you are going to get, as part of the answers you had. Okay, so this integral is equal to 7 raised to the power 2x plus 10 divided by 2 ln 7 plus c. All right, but mind you, somebody may be thinking that the solution is not correct. So in my next video, I'm going to differentiate this answer. You know, differentiation and integration, sometimes they move together. Okay, when you integrate this and you had this, when you differentiate it, you should get this at the end of the day. So in my next video, I'm going to differentiate this answer, and if I do so and I get this one, it means the answer to this integration correct, which is integration question, which is this one, is what? Correct. So in my next video, I'm going to differentiate this one to find out if we will be able to get this one. Okay, all right, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.